Okay, today we're looking at surds, and surd, of course, is any irrational number, so the nth root of a, for example, and of course where a has to be greater than 0. Alright, and n is an element of positive integers. So anything like that would be surd. Now in this bit we're not going to look at anything really other than n is a rational number, or a is a rational number I should say. Alright, so example on that, so square root 21 is a surd. Alright, because that's the only way that we can really describe it. 3 sevens is 21, so we can't simplify that any further. But square root 36, for example, is not a surd. And the reason why it's not a surd, again, is we're getting more technical here, and there's going to be a lot of technical stuff for the rest of the year, and that's one of the things that you need to learn about and remember, because that's where it gets to next year. Because square root of 36 is 6, so we can simplify that and write it as a whole number, and so that's not a surd. Okay, so let's look first of all at some simplifying. So, for example, so let's look at this simplifying. So simplifying first of all, we'll have a look at things that can be simplified. So square root of 8, for example, we can simplify that. How can we simplify that? Because we can write it as 4 times 2, and then we're allowed to split those up. And the square root of 4 is 2, so we've got 2 square root 2. Now the square root 2 part can't be simplified any further. So there would be a simplification for that one. So something like this, 3 square root 405, for example. Alright, the 3's use the 3 out front anyway. And then need to look for factors of 405. And I'm reckoning that 5 will be going into it, which it does, and in fact it does 81 times. So you'll then notice that 81, of course, is something we can simplify, because square root of 81 is 9, and so 3 9's 27, 27 root 5 for that one. So really we are looking for the numbers in these positions here. They need to be perfect squares. Alright, so and then if we do another one, so negative 1/8, square root of 175, so negative 1/8 is out the front. So we're looking for numbers that go into with 175, of course 5 will. 5's not a perfect square, so what perfect square goes in? Well, 25 certainly does. How many times does it go in? It goes in 7 times. So we've got negative 1/8 times 5 times root 7 is negative 5/8 root 7 on that one. Alright, so that's simplifying for us. Okay, adding and subtraction. And we can add and subtract as long as the surds are the same. So if our surds are the same, then we can add or subtract. So they're going to be the same type of thing. So for example, 3 root 6 plus 17 root 6. Take 2 root 6. So these surds are all square root 6. So we've got 3 lots, we add 17 lots, and then we take 2 lots of square root 6 away. So how many lots of square root 6 have we got in the end? Well, 3 plus 17 is 20, take 2 is 18, so we got 18 lots of root 6 there. And there may be times where we need to simplify first, and here's an example of that. So 5 root 3, well, that can't be simplified any further. That stays where it is. Well, 12 can, because it's 4 times 3. We've got negative 5 root 2, that can't be simplified. And 8 can, of course, because that's 4 times 2. So we've got 5 root 3 plus square root of 4 is 2 times the 2 that's already there. So that's 4 root 3. 5 root 2 can't. Okay, square root of 4 is 2. 2 times the 3 that's already there, 6. 6 root 2. Okay, so now it's kind of like adding together like terms now. I made a bit of a mistake here. I've written around the wrong thing there. It's 6 root 2, not 6 root 6. So what we can do is we can, collect our like terms, so to speak. So you've got 5 root 3 and 4 root 3, so we've got 9 lots of root 3. We've got negative 5 lots of root 2, then we add 6 lots, so that's plus 1 lot of root 2. Okay, so that's it, addition and then subtraction. Just got to remember, they've got to be the same. Alright, a multiplication. Okay, multiplying the surds. It's a pretty simple process, really. And we multiply surds in very similar fashion to when we do other things. So, okay, so it's got root 3 times root 2. We can put them in 3 times 2, root 6. Okay, so that's a simple one. Sometimes you may be able to simplify. So for example, 2 surds that can't be simplified, square root 2 times square root 6. When we multiply them, we get square root 12, which of course we can, because that's 4 times 3. So 2 root 3. So the expectation is, in this case, that you simplify that square root 12 where you can. Something like this, we can have brackets, and the same laws for expanding occur here as anything else. So we have root 6, so multiplying that in there, and multiplying that in there, plus root 12. Root 6 can't be simplified, root 12 can be. We just did that in the previous example, 2 root 3. Alright, so you can have double brackets, and so it's just like binomial expansion in your algebra. So we've got a bracket like that, so it's just exactly the same as your algebra. That times that, that times that, which is square root 9 minus 2 root 3, and then this times this times this, same as, so 1 root 3 and minus 2 on the end, and square root of 9 is 3, 3 take 2 is 1, minus root 3 is the answer for that one. Okay, so we have a thing called a conjugate. Conjugate. So if we have square root a plus square root b, then square root a minus square root is the conjugate. And a very interesting thing occurs when you multiply something by its conjugate. So root 3 minus root 2 multiplied by its conjugate root 3 plus root 2. Interesting thing happens. So you get root 3 times root 3, which is root 9. You get minus root 3 times plus root 3 times plus root 2, which is root plus root 6. Then you have minus root 2 times root 3, which is minus root 6. And then you have minus 2 2's are 4, square root 4. Now you'll notice that we've got plus root 6 and minus root 6, so they cancel. Square root of 9 is 3, and square root of 4 is 2, so you end up with 3 minus 2, which is 1. So you'll notice that with our conjugates, the square roots are eliminated, which is quite handy later on. Alright, the last thing we're going to look at here is division. And division of surds, we need 2. Right in forms of a fraction. So if we're having root 3 divided by root 2, for example, we need to write it as root 3 over root 2. And then we need to rationalise. Okay, so in this case, to rationalise, we've got to get rid of the root 2, so we need to times top and bottom by root 2. On the top, our numerator, we've got root 6, and then our denominator, we've got root 4, which is 2, so root 6 over 2. The expectation is that you give all your answers in rationalised form. Now, for example, if we have something like this, and I'll get a new page for that, we have something like square root of 7 minus 2 root 2 over, divided by square root 7 plus 2, square root of. Got another bit of a blue here, that's supposed to be square root 7. Okay, alright, so we need to rationalise that denominator. And that's where our conjugate comes in, because remember when we multiply something by its conjugate, the square roots go. So we need to multiply top and bottom here by the conjugate of what's on our denominator. And that's square root 7 minus square root 2. And we need to multiply top and bottom by that. So on our top line, square root 7 times square root 7 is 7. Square root 7 by minus square root 2 is minus square root 14. Then minus 2 square root 2 times square root 7 is minus 2 square root 14. And finally minus 2 square root 2 times negative root 2 becomes negative and negatives are positive. 2 root 4, which of course is 2, so that's 2 times 2 on the end, all over square root of 49, which of course is 7, minus root 14 plus root 14 minus root 4, the square root 14's cancel. So on our numerator we have 7, let's get rid of that. That's not. We get 7 plus 4, which is 11. Minus root 14 minus another 2, so it's minus root 14. And on our numerator, we've got square root of 49, which is 7. Take the square root of 4, which is 2. 7 take 2 is 5. Okay, so there you have it for your surds. So we're now up to exercise set number 3, exercise 1C. So you can have a go at that.